All right, so we're going to continue with example 2, which is looking at mortgages from this bank. And it says scale the years somehow. So this time we're going to do, for the scale, years since 1970. So for my first data value of 1970 in the year, that's going to be year 0. Now, when you're typing in these values, be careful. It's only asking us to model 1970 to 1988. So just do not include those last 3. So make sure when you're typing this in, you do not include those last 3. So here is the second example. I'll go ahead and scroll down, and you can see how I only went to 18 years since 1970. So 18 plus 1970 gives me that 1988 number. So make sure you're just stopping when you get to the 1988, 18 years. So let's just take a look at the raw data to see what we're working with. So insert data and statistics. I'm going to say year explains the mortgage value. And that looks like a pretty distinct curve. So right away, I'm going to go ahead and say the raw data is no good. All right, so now I'm going to work with squaring that data. So I'm going to square my y values, in this case, the mortgage values. So column C is going to be the square SQ of mortgage, so square mort. All right, then I'm going to write equals. I'm going to type in mortgage. All right, and I'm going to square it. All right, so I'm going to go back to my scatter plot, and I'm going to type or click square of mortgage, and that makes it actually even more of a curve. So that is not ideal. So I'm going to go ahead and X that one out. That didn't work. Go past raw data. Now we're at the square root of mortgage values. So go to column D. I'm going to type in square root, SQRT of mort. So square root of mortgage. So I'm going to write equals square root of mortgage. Type in mortgage. Oh my gosh, again, no M. Come on now. Here we go. M-O-R-T. A-G-E. Yes, success. All right. Let's see what that looks like. The square root of mortgage. Oh, that makes it look a lot better. Let's see if the model is appropriate. So I'm going to insert a calculator page and run the model. All right. Stat calculations, A plus BX. My explanatory is year. Don't forget we re-express to the square root of mortgage. And we always have to check the residuals. So I'm going to put year, and then my response is the residuals. And, well, it's up to you. You can obviously work with that model if you want, right? If you think that's the most useful. But honestly, when I was doing this, if I go back to the original mortgage, I look at this and I think, this is like a pretty distinct curve. And that reminds me of a function that I've worked with in the past, the exponential function. And when I taught you guys exponentials back in Algebra 2, if you were in my class, we also discussed logarithms. So I'm actually going to go ahead and use the log of mortgage. So you guys can work with logs again. All right, so I'm going to write equals. Now, you can use the common logarithm, which is a base 10, or you can use the natural logarithm, which is going to be the base of e, whichever one you're comfortable with. I do not care. So if you do the base 10, you'll do this one, you'll type in 10. Or if you want to use the natural log, you would use that one. But it's up to you. I'm going to use the common logarithm just so that we feel good about it. So I'm going to go down here, equals common log, base 10, and type in mortgage. Got an M? Great. G-E, excellent. I'm going to go back to my original scatter plot, type in the log of mortgage, and it looks, pretty similar to the square root. Go to my calculator page, run the model. All right, just to see what that looks like. So I have year explains the log of mortgage, F2, by the way, that's where it's stored. And then I have to check the residuals. Don't forget to check them. And you can see, maybe a little bit of fan shape where the spread of it is shrinking down. But you know what? For our purposes, I'm going to go with that. The log is our best and most useful model. Again, we know it's wrong, but I'm going to use it because it's our most useful one. So I'm going to use these numbers here. The y-intercept is 0.146201, the slope of 0.074037. Again, rounding I'm going to do, but you don't have to, whatever you prefer. So here we go. I have the log of mortgage hat equals 0.1462 plus 0.007 times year. And again, that's year since 1970. So it wants me to compare these post-90s mortgages. So what I'm going to do is I'm going to find what the model predicts for 1990, 2000, or 1995, and 2000. Now I'm going to show the work for 1990 so you remember how to deal with logs. So I'm going to type in F2, and it would be years since 1970. So 1990 is 20 years since 1970. So F2 of 20. Now, that says 1.62694. So again, if you look at the numbers, that doesn't make any sense because we've been up near the 30 millions, right, when we get to 1990. So that is saying the log of mortgage hat equals 1 point, let me just write it again, what it is, 1.62694. 1.62694. Okay? So now, in that case, 1990, we don't expect it to be 1.6 million because, it's telling us it was 32 million. So something's wrong there. That's because it's not mortgage, the prediction value. It's the log of it. So if this is a base 10 and you want to switch it to exponential, you go 10 to that power makes the mortgage. So I'm actually going to do in my calculator 10 to the power of 1.62694. And that will give me my prediction value. So I'm going to write 10 to the power, and if you just scroll up and hit enter on that guy, it'll put it there in the exponent, and you get a prediction of 42.36 million. 42.36 million. So 1990 is 42.36 million. All right, and that makes a little bit more sense considering that it tells us it was actually 32.4. Yeah, it's not exactly correct, but it's more in the ballpark than 1.6 million. So I'm going to go ahead and do that for 1995 and 2000 and see what we get. So F2 of 25, and again, that's not the actual number. I have to do 10 to that power. And that one is 99 million. So wow, that's really high, 99 million. That's for 1995. And then let's do 2000, or year 200. Year 2000, which is going to be 30 years since there. So F2 of 30. When I do 10 to that power, and if you do that, you get 233 million, basically. 233 million. And that does not make any sense. So our model is definitely not useful because compared to what it says in the table, 2000 was just under 50 million, but my model is predicting over or almost 233 million. So that doesn't make me feel very confident about the use of this model. But anyway, that's not the point of this. The point of this is you feeling comfortable going through the process of re-expression. So beginning with the raw data and then this beautiful work here to find your best model. Again, we're not saying it's right. Maybe it's useful. All right, so that's example 2.